Conservation of Momentum and Laws of Motion, Part 1. For many centuries, motion and its causes had puzzled scientists. A ball on the ground, when given a small hit, does not move forever. Such observations suggest that rest is the natural state of an object. This remained the belief until Galileo Galilei and Isaac Newton studied and developed some theories and laws of motion. In order to move an object from its place, we have to either pull or push it. This is nothing but applying force on the object. For example, we have to push the trolleys in order to move them forward. That is, we apply a force on the trolley so that it changes its state of motion and moves forward. By observing the motion of objects on an inclined plane, Galileo deduced that objects move with a constant speed when no force acts on them. Galileo observed that when a marble rolls down an inclined plane, its velocity increases. Its velocity decreases when it climbs up the plane. In a case when a marble is resting on an ideal frictionless plane inclined on both sides, Galileo argued that when the marble is released from the left, it would roll down the slope and go up on the opposite side to the same height from which it was released. If the inclinations of the plane on both sides are equal, then the marble will climb the same distance that it covered while rolling down. If the angle of inclination of the right side plane was gradually decreased, then the marble would travel further distances till it reaches the original height. If the right side plane was ultimately made horizontal, that is, the slope is reduced to zero, then the marble would continue to travel forever to reach the same height that it was released from. The unbalanced forces on the marble in this case are zero. Thus, it suggests that an unbalanced external force is required to change the motion of the marble, but no net force is needed to sustain the uniform motion of the marble. In practical situations, it is difficult to achieve a zero unbalanced force. This is because of the presence of the frictional force acting opposite to the direction of motion. Thus, in practice, the marble stops after traveling some distance. Newton further studied Galileo's ideas on force and motion and presented three fundamental laws which govern the motion of objects. These three laws are known as Newton's laws of motion. The first law of motion is stated as an object remains in a state of rest or in uniform motion in a straight line unless compelled to a change in state of motion by an applied force. That is, all objects resist a change in their state of motion. The tendency of an undisturbed object to stay at rest or to keep moving with the same velocity is called inertia. Hence, the first law of motion is also known as the law of inertia. Certain experiences of our daily life can be explained on the basis of the law of inertia. While traveling in a car, we tend to remain in the same state of motion as that of the car. When the driver applies sudden brakes, the car slows down, but our body tends to continue in the same state of motion because of inertia, and thus we experience a forward jerk, or sometimes it can be injurious. Thus, safety belts are worn, which exert a force on our body to make the forward motion slower. When we are standing in a bus and the bus begins to move suddenly, we tend to fall backwards. This is because the sudden start of the bus brings motion to the bus as well as to our feet, which is in contact with the floor of the bus. But the rest of our body opposes this motion because of inertia, and thus we experience a backward jerk. Let's perform some activities for the illustration of the first law of motion. Make a pile of carom coins on the carom board. Hit at the bottom of the pile with a striker. If the hit is strong, the bottom coin moves out without disturbing the pile. This is because when the lowest coin moves quickly, the inertia of the other coins in the pile makes it fall vertically on the carom board. Set a 5 rupee coin on a stiff playing card covering an empty glass. Flick the card sharply. If you flick the card fast, then the card shoots away and the coin falls vertically into the glass due to its inertia. All the examples that we have seen so far illustrate that an object will always resist the change in its state of motion. That is, if it is at rest, it tends to remain at rest, and if it is moving, it tends to keep moving. This property of an object is called inertia. All the objects do not have same inertia. For example, instead of a 5 rupee coin, if we use a 1 rupee coin, we find that a lesser force is required to perform the activity. If we kick a football, it flies away. But if we kick a stone with the same force, it will hardly move. Here, a 5 rupee coin or a stone has a lesser tendency to change its state of motion. We can also say that both these objects have more inertia than a 1 rupee coin or a football. Heavier or more massive objects offer larger inertia. Inertia of an object is measured by its mass. Thus, inertia is the tendency of an object to resist a change in its state of motion or of rest, while the mass of an object is a measure of its inertia.